Okay, so free surface moments. Okay. Okay, so slack tank, no? A tank is neither full nor empty. So, okay, it is not totally full or empty. The liquid here is free to move, no? And thus possesses an inertia. Okay, the center of the gravity of a liquid that is free to move is not anymore at its geometric center, but is somewhere above the liquid. This will cause the ship's center of gravity to rise. Okay, so this is the tank, slack tank, no? The breadth and the length. So again, we will use this density of water. Example, no? The salt water. So if we will use the English formula, system formula, so that is feet. So 35 cubic feet per tons. Or in metric, 1.025 cubic tons per cubic meter. Or in kilograms, 1,055 cubic meter. So the formula in taking, by the way, we have also the ratio. AR is a ratio. So we will take this one if, for example, the the density inside the tank is different from the vessels where she is afloat. Let's say, for example, the specific density or relative density of the water inside the tank is 0.785, while the ship is floating on salt water, no? Salt water 1.025 metric tons per cubic meter. So they are different. That's why we will take first the ratio. So the formula of ratio is specific gravity or relative of liquid in the tank, no? And then divided by specific gravity or relative density of water where vessels afloat. Okay, so sample problem, no? Find the free surface constant FEC for a tank of 70 feet long, 35 feet wide, and 25 feet deep. The displacement of the vessel is 35,000 tons. The specific gravity of the liquid in the tank is 0.782, and the vessel is floating on a density of 1026 kilograms per cubic meter. So solution, we will use English system since given unit are in feet. Okay, so the formula, free surface correction equals ratio times length times cubic breadth, no, divided by 12 times density of water. So since there is a ratio here, no, see, as you can see, the liquid inside the tank's specific gravity is 0.782, and we will divide this divided by this to 1.026. Okay, the density of the waters where she is floating. Okay, so the formula now is 0.782 divided by 1.026 times 70 feet times 35, 35, 35, 335. Okay, divided by 12 times specific gravity of the water. So again, we use the English system. Okay, okay, density of water, no? Okay, okay, so the answer is 5446.4. Okay, okay, feet per ton. So next, the displacement of your ship is 8,000 tons on salt water. The double bottom tank measures 20-meter long times 16-meter wide, partly loaded in seawater. Calculate the free surface constant. So we will use metric system. Why? Because the unit given are meter. So the formula of the metric system is FEC, free surface correction, equals ratio times length times cubic breadth times density of water divided by 12. So note that the specific or relative density of the liquid in the tank is assumed to be salt water, and the vessel is indicated that it is floating in salt water. Thus, the ratio is equal to unity. So we will not use this anymore because again, the specific gravity of the water inside the tank is also salt water. Okay, and the vessel itself floats in the salt water. So we will not use the ratio anymore. Instead, we will go directly here. Length times cubic feet times density divided by 12. So the now 20 meters length times 16 times 16 times 16. 16 times 16 times 16. Okay, times the 20, no? And then times 1.025 tons per cubic meter because this is metric system. Okay, divided by 12, the answer is 6,997.33 meters per ton. Okay, so now let's go to the free surface effect. What is the effect? They said if there is a slack tank, there is a virtual rise of the center of gravity. So that is GGO. Okay, a liquid or bulk that is free to move will cause a virtual rise of the center of the gravity of the vessel. That is a shift of G that always moves upward. Always moves upward and termed as GGO. So GGO, free surface correction, reduction to GM, loss of GM divided by loss of GM or gain in kilograms. Virtual rise of G due to free surface. Example, a deep tank is half full of water. Therefore, this is slack, which has a rectangular free surface of 30 feet long and 25 feet wide. The shape displaced is 2,050 tons. Here, kilograms is kg, not kilogram. Kg is 18.7 feet. If the effect of the free surface is ignored. Solve here actual kg, allowing for the effect of the free surface. So solution, we will use English system. Why again? Because the unit is feet. So ratio is not used, no, it's not needed. Okay? Because again, the specific gravity inside the tank and the water itself, the vessel itself, no, she is floating in the salt water. So we will not use this ratio anymore. Okay, so this is the formula, no? GGO equals ratio times length times cubic breadth divided by 12 times weight. Weight here is a displacement of the ship times density of water. So again, since we do not need to use this ratio, okay, so we will cross this one. Instead, we will use the length times cubic breadth, no? Okay, now find GGO. So the length of the tank is 30 feet. Okay, GGO equals length of the tank times, okay, 25, no? 25 times 25, no? And divided by 12 times 2,050 displacement of the ship times 35 cubic feet per ton. Why we use 35 cubic feet per ton? Because this is English system. Okay, feet. So the answer is 0.54 feet. So your GGO, transfer of G, shift of G is 0.54 feet because of the slack tank. Okay, apply GGO to all kg. So since we all know that the old kg is 18.7 feet, 0.7 feet. Okay, so the rise of GGO moves upward. Okay, so old kg 18.70 feet plus y plus because the G moves upward. So the new kg, the kg now is 19.24. There is a rise of kg, increase of kg, and decrease of GM. Okay, so the new kg now, kg is, this is not 18.70 is not km, ha, but it's kg, no? Kg, no? Sa my mistake. Okay. Okay, moment ha. Okay, so again, for avoid confusion, kg is 18.70. So since there is a rise of shift of g, no, upward, GGO, okay, the new kg is 19.24. So as you can see in the illustration, kg is increasing and the GM is decreasing. So, okay, GGO always moves upward because it is added to all kg and subtracted to all GM. Okay. Okay. Next example, no? The displacement of your ship is 8,000 tons on salt water. Okay, the displacement of your ship is 18,000 tons on salt water. The double bottom tank measures 20-meter long and 16-meter wide. Partly loaded with salt water. So partly loaded meaning this is slack tank. Calculate the effective GM. If the KM is 7 meters, okay, 7 meters, and the kg is 6. So obviously your GM is 1 meter. So since there is a virtual rise of G, so there is a changes now. This is why what I'm going to compute to solve now. Solution, no? So again, we use metric system. So the formula, okay, again R is not needed. Formula is 20 meters length times breadth, cubic breadth, times density of water divided by 12 times 8,000 tons displacement. The answer is 0.875 meters. So that is your GO. Okay. So now this also in connection with the problem solving here. Huh? So the displacement of your ship is 8,000 tons in salt water. So again, the double bottom tank measures 20 meters long and 16 meters wide. So again, partly loaded with salt water, slack. So calculate the effective GM if the KM is 7 meters and the KG is 6 meters. Therefore, given KM is 7 meters minus KG, your GM is 1, correct? So since there is a rise of rise of KG and reduction of kining GM, so at first your GM is 1.0, correct? Since it rises, okay, so M G E E. So this one, your GM is 1 meter, correct? So since G is moving upwards, shifting upwards, GGO here, so it becomes this GM, it becomes 0.125 meters because the rise of G is 0.75. Okay, that's the reason why your GM is reduced to 0.125 meters, and your kg is also increasing. Okay,